Hi there, this is Hans Forschner with Navcon Engineering, and I'll do a quick introduction or give a general overview for the SoundPLAN Essential Software version 2.0. This here is the project settings overview. In this overview, we set up the project name. You can put in your project number, who's working on the project, customer, and any kind of description that you want to put into. So in this project, we'll have a backup generator. I'll model it as a point source, a rooftop HVAC system also as a point source, some retail parking lot, and the road noise model. In regards to the setup, we have several options in regards to that we can set up a single variant. So it's basically with whatever configuration we see, or without and with noise protection, and that basically means we can add a barrier into the model, and then the program will calculate with and without that specific barrier. So a barrier would be marked, and so to get these two variants, we get a marker set on a barrier. Then the third one I don't want to discuss really at this point. Here we have the types of noise sources. Here we have different combinations. In general, there's industry, road, and parking lot. The presentation I'm doing will show all three sources active at the same time. So that means all the prediction will be including all three sources. We can also select just to look at the industrial sources, or to select just to see the road sources. But again, for this view, I'll show all of them. And we'll see here in a second where we can configure that. Now, on the standards and calculation settings, we have all the default settings that are important for this project and also for the software. First of all, country settings, manual, English, and all that. And then here, these are basically the current set standards for this project. If I delete all the results, I can reset that and make changes and run the model with, for example, a different road model or different rail or industrial model. And we have time slices. This is basically just defining if you have one or two or three time slices. The third time slice basically would add an evening hour. So in this case here we have defined for the US a daytime from 7 to 10 o'clock in the evening, and then from 10 o'clock till 7 o'clock in the morning, the nighttime. Again, this can be changed when we delete the results. So if you start a project, of course there is no results, and then you can set up your configuration or your time slices or your standards. And under noise type combinations, here we select which standards we want to use for the project. So we have configurations for different standards. Again, here I can't change it because it's already calculated, but basically there are pull-down menus that you can select from. We have different combinations of sources that we basically define here. In this case, I have 4 different types of combinations, and so for each case, for each combination, I can run the model just with the industrial sources. That means point line area sources, the road noise sources, the parking lot, or in this case the fourth, a combination of road, industry, and parking lot. And under calculations are some of the defaults in regards to the number of reflections. If we want to add any kind of corrections for rail noise, so that's this bonus. That's actually a implementation that is for Germany, where they apply a 5 dB bonus for rail noise, so meaning the rail noise is not quite as impacting as road noise or industrial noise. Then here we have other correction values. Then here temperature, humidities, and air pressure. That's for industrial source calculation. And then below some defaults in regards to the height above ground for grid noise maps, or the grid spacing. So again, the grid calculation every 5 meter point. And then for limit lines, if you calculate instead of the contour maps, you want to calculate specific lines, you can set it up at whatever height. Then on the receivers, there are several defaults in regards to number of floors, the delta between the floors, and some of the labeling. So I don't really want to go into detail here. And then point sources, also a couple of defaults. So I'll click OK. So in this case, this is all the setup. And Let me continue with the editor, kind of showing you a little bit on the editor, and then continuing through the tables, source input tables, result tables, and the graphic plots. This is the editor, and with this editor we also kind of see the view of the area in terms of the input data and then also the aerial map in the background. The aerial map is scaled, so here we have on the edit we can initialize a bitmap. What the initialize means, it's you're scaling the bitmap, so you're selecting in this case the let's see, the area like this one, and you're basically entering. Let me make that a little smaller. So this is the aerial bitmap. So you're entering basically 2 points. On in this case, it's a left and top right corner. We know the coordinates, and you basically just enter the bitmap coordinates, and you're defining what are the world coordinates of these bitmap coordinates. And so you click OK, and then after that, every point within the bitmap is scaled. Or kind of the program knows what the coordinate is, and in this case it's a local coordinate system. If you had the actual world coordinates in UTM, you can also use UTM coordinates. To turn on and turn off the aerial maps, we have here the selector, so no bitmap, so we see the raw data. And then let me just show you some of the views. So we can, with a magnifying glass, we can zoom into certain areas. We can zoom out using just the wheel on the mouse. We can change and show a vertical map. The vertical map, we can zoom in. Basically, it gives us a way of looking at the side view. That's in a lot of ways a good kind of like check if the elevation information is all consistent. And then here we have a vertical 3D view, and here we have the option to change, rotate. So with the hand I can rotate, and then we can change the tilt angle and get an idea of the geometry. So here we have the geometry. We can move that. Yeah. And the blue boxes are representing buildings. The red dots are representing sources, in this case point sources. The purple area in the background is the parking lot, and the red lines here in the background are the road source at different elevations. You can actually see 3 lines for each lane, and that represents, for the TNM model, the 3 sources. Let me turn that back to sitemap. And so here we have different objects that are entered. You can see at the very top, we can save the data that's entered. We can turn on the right angle mode when we're digitizing from the aerial map. There's a text that we can enter for example, the house numbers. Then we have a general line. These are basically just general like object types. And then following are object types that are defining the geometry, either in terms of a point elevation, so there is a spot heights, line, contour lines. And in terms of this input, I entered a contour line around this block, defining it all at 230 meter elevation. So I digitized around this area. If I added, for example, elevation line, we could, for example, go right here and put in a 230 meter elevation, for example. So that will be added later on in the digital ground model. What you see here in the background is actually the triangles. So the program will triangleize all the elevation data, including spot elevation and line elevation, and triangleize it to develop a digital ground model. And the digital ground model, again, it's developing the smallest triangles between elevation information it finds. And with that, the program knows exactly, as we digitize from that DGM, it already knows what is the base height or the terrain height at that point.